For this video, let us define the Lebesgue outer measure. Now, before we proceed to Lebesgue measure, let's talk about the Lebesgue outer measure. And again, we'll be writing here, and we're going to illustrate what does the Lebesgue outer measure mean. So here is its formal definition. Let M asterisk be a mapping from a power set of the set of real numbers to 0 and positive infinity. So this is also bracket here. Be defined by, here its definition, M asterisk of A is equal to the infimum of the summation of the length function of intervals I sub n, where n starts from 1 to infinity. Okay, this is the definition for Lebesgue outer measure, where where infimum is taken over all countable collections of the set containing the interval of open intervals with A, in this case, is a subset of the union of I sub n, where n starts from 1 to infinity. Okay? The function M star is called the Lebesgue outer measure. Okay, so this is how we define the Lebesgue outer measure. That it states that this notation for any A, which is of course a subset of the set of real numbers, is equal to the infimum of the summation of the length of intervals I sub n, where n starts from 1 to infinity. So, what does this mean to us? It is actually a way to assign the length or a size to any subset of real numbers. So we're going to talk about covering, or how much space it takes up on a number line. You are going to imagine a certain set, let's say set A here, and its Lebesgue outer measure is actually the covering to completely cover that said set A. Okay? Here are some illustrations. If we have a certain set A sub 1 being a finite set, okay, a singleton which is 5, its Lebesgue outer measure, okay, A sub 1, is equal to the infimum of the summation of the length of I sub n, where n starts from 1 to infinity. I mean the length, okay, the length of your I sub n. Okay? But since I sub n is an interval and this is no longer an interval, its length is actually 0. That's why its Lebesgue outer measure for a singleton like this is 0. Okay? Now, for a specific interval, let's say 1 and 4, the Lebesgue outer measure of A sub 2 is the infimum of the summation of the length of your interval I sub n, where n starts from 1 to infinity. So what we want here is the smallest total length that will cover the interval. Take note that in our interval, 1, 2, 3, 4, this is 1, this is 4, and we have here the shortest possible length that would cover this is of course the length of the interval itself, 1 and 4. That's why we have here this one, which is 4 minus 1. That's why it's equal to 3. You can use smaller values closer to that, but obviously it's just 3. So that's how we look into the Lebesgue outer measure. It's the covering of a certain set. Okay? If we talk about another set, let's say set n, take note, set of natural numbers would be the points here, let's say 1, 2, 3, 4. So it's a collection of singletons, right? 1, 2, 3, 4, dot, 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 okay, so on and so forth. Again, if we're going to construct the cover for them, this is very small, that's why there's no covering for each. It could actually be 0 for each of them. At the same time, we talk about the union, okay? A should be a subset of the union, but here, this means the covering for N is also equal to 0. We will also have more discussions as to this, but as for the definition of the Lebesgue outer measure, it's okay to have that in the meantime, as long as we're able to understand that it's talking about covering a certain interval. And if its interval is just like singleton like this, so it's 0. And we also have, again, other illustration for that in the next few videos. Thank you very much for watching.